All right. Okay, so this is assignment 18, station models. If I already spoke to you if you're in the group, so if you are watching this video, you are in the independent group, or you're at home and you're watching it on your own time, which is great. Here are the groups again. Agenda, we're going to be working with station models, and you're watching this video. Okay, so our aim or goal is to diagram station models. Sorry, I'm going to hide this really fast. Cool, so let me use this pointer. So what we're doing, you're going to need to open page 13 of your reference table. Page 13 should have this chart within it. As you can see, it is on page 13. And this shows you the station model diagram and what each item represents. Okay, you will learn what a station model is and how to label it today. So it's pretty fun. Obviously, you can see there is a lot going on here in these station models. You have, like, this is an example of a model. These are, what you include in your station models. I'm just going to break it down for you a little bit more, okay? So again, here is like a big view. If you don't have your reference sheet, I have one. I have actually like 20 that I printed out for you guys just in case. So let me know. Okay, so station models were created for newspapers actually a long time ago, and this would make it easier for people to understand the weather in a specific time or in a specific city. So for example, like, what is this station model? Well, look at all this. This is an example of one, and it's just a diagram showing the weather conditions for a city on a map. All weather variables are located in specific places on the station model and are given in a symbolic form without the units. Okay, as you can see here, these do not have any units, they just have numbers. And the thing for that is that it makes it easier to read. And we did have units on here, it would be just too like stuffed together. It would just be like disorganized and too much stuff is going on. So that's why it's like this. All right. So for a station model, you always start with a circle. Units are not added in the station model, remember. So you always begin with a circle, just like this. And then on the upper left-hand corner is where you put the temperature. The temperature is always in Fahrenheit. Go ahead and draw this on the paper that I gave to you. Draw this on the paper that I gave to you. So in the paper I provided for you, on the second page in the back, draw this. Draw this and label it just like that, okay? It is actually more beneficial for you to write this out rather than to just watch it and, that's it, and take it in. Draw it. Temperature, Fahrenheit, upper left-hand corner, no degree sign, no F sign, just put the number, okay? And then on the middle right-hand side, or left-hand side, rather, the middle left-hand side is the visibility. So the visibility is like given to you. They can say it's like, oh, it's a 4% visibility, 10% visibility, and that's what you're going to write outside in the outside middle left of the circle. There's actually two things that get written here, but we'll get to that. And then on the bottom left-hand corner is dew point. Dew point is provided to you as well. Like I said, do not put any degrees. Do not put any degrees, okay? Just put the number, the number, the number, the number. I'm going to say that 20 more times. Number, 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 just the number. Okay, and then in this middle portion right here, this is also in the middle next to visibility, just more in, is the current weather condition. So it can be, the weather condition be partly cloudy, rainy, so on, so forth, and it'll give that to you so you can label it in there. Okay, I should see this written on your paper, guys. If I don't, then there's an issue, and we can work in the dependent group. Cool. So the next thing that you're going to write inside the circle is the cloud cover. Okay, the cloud cover is what you're going to shade the circle. So if it's 25% cloud cover, you would shade in just like a quarter of the circle. If it's 50%, you would shade in 50%, right? And you would bubble that in. If it is 100%, then this whole circle should be shaded in, just depending on how much cloud cover you have. Okay, so it's just a shading in for the cloud cover. The next thing, which is actually my favorite part because this is like more drawing, is the wind direction. The wind direction is just a straight line out of the circle, okay? So the direction of wind depends like of course, like where it's going, north, south, east, west. The circle represents, like, just think of a compass, right? Here's north, south is at the bottom, east, okay, and then west. So the line for wind direction is drawn out of one of these sides, depending on the direction of wind where it's blowing. So say that we were to draw it here, okay? Where is the wind direction? What is the wind direction? How do you know? The wind direction is northeast. I know this because it's in between north and east, okay? It's not exactly east. If it was east, due east, and it would just be directly right here, shooting out toward the right side. But it's not. It's just like toward the middle. I should have moved this over a bit, but you get the picture, okay? Northeast. The next thing is wind speed, okay? Wind speed, to represent that, you're going to draw lines out of the lines, okay? So lines are coming out of this main wind direction line. So we start out with the direction, and then we get the speed. So if we look at our chart, at our reference chart, it has this in here, and this like these symbols represent wind speed. So these are like the little feathers. They're called feathers, which is kind of funny. You can think of them as feathers. There's a whole feather, which is this long one, and there's a half feather, which is a shorter one. A whole feather represents 10 knots. That's the speed, like in knots. You can think of a knot as 1 mile per hour. And then the half feather, the smaller one, represents 5. So if we were to count how many feathers or half feathers there are, we would count the big ones, like this one, I know that's 10. This smaller one, I know that's 5. So in total, 10 plus 5 equals, that's right, 15. So that's why you have 15 knots. Okay, so that's how you determine it. Pretty easy. So let's try it out. Say I have this long one and this short feather. So we have a long and a short feather. So how many knots do we have? I hope you said 15 because 10 plus 5 equals 15. So yes, it was 15 knots. Cool. Super easy. Like I said, that's my favorite. It's just a little fun. The next thing that we're going to do is barometric pressure, okay? So the barometric pressure, just like how these are on the left-hand side, the barometric pressure here is on the right-hand side, the upper right-hand corner. And with the barometric pressure is usually written in decimals, like it's like 1093.5, right? That's an example. Well, you're only going to write the last 3 digits of that number. So, for example, the barometric pressure of this like example is 1019.6, okay, millibars. But if we're writing it here in our station model, we are only going to write the last 3 digits. Only write the last 3 digits. You are writing this down on your paper now, okay? Only the last 3 digits. So the only thing that we would write here, last 3, 1, 2, 3, I like to start from the back. It's 1, 9, and 6. The other thing you have to remember is that, see here how it's a whole number? You do not need to write the decimal, okay? It's already assumed that there's a decimal. So you don't need to write a decimal here. Just write the last 3 digits of this entire like quantity, okay? So 196. Cool. This one could be a little tricky sometimes if you don't remember. This is like something that you do have to remember on memorization. But the next thing, which is a barometric trend, it's not that hard. So it's going to let you know if the pressure is rising or if the pressure is dropping. If the pressure is rising, you add a plus, right, because you're adding on the pressure. If it's dropping, you add a minus because you're decreasing the pressure. So if it says the temperature is rising 3.5, you would put plus 3.5, okay? No decimals, just same thing as here, just add 3.5 because it's assumed that a decimal is already between it. Cool? Okay. Awesome. And then the last thing is the precipitation. The precipitation is written on the lower right-hand corner of the circle, okay, of our station model. And it'll say like precipitation is like 5%, then write 5. Just write 5, not the percent, no decimal, no degree, just 5. Cool. So let's practice. All right. The weather station model shown below indicates that winds are coming from the